All right, the last section covers questions 14 to 16. So let's take a look. It says Monica gets on an elevator in a skyscraper. The elevator starts to move at a rate of negative 20 feet per second. After 6 seconds on the elevator, Monica is 350 feet from the ground floor of the building. Number 14, the rate of the elevator is negative. What does this mean in this situation? And what value in the slope-intercept form of the equation does the rate represent? So what does it mean for her to go negative feet per second if we're on an elevator? It means that the elevator is going down. And it asks, what does this represent in our slope-intercept form? Now, if you recall, the slope-intercept form was that y equals mx plus b. So would this represent my m, my slope, or would this represent the b, my y-intercept? I have to agree, this is definitely going to represent my slope, or if you want to call it my m, okay? It represents the slope. We're going downward, and the slope is going to be negative 20 feet per second. Number 15, A. How many feet was Monica above the ground when she got on the elevator? And show how you determine that. Okay. Well, what other piece of information was I given besides the fact that we're 20 feet per second? We know that after being on the elevator for 6 seconds, she's currently at 350 feet. So we're going to start with 350, okay? Because that's one point we do know, but that's after she's been on this elevator for 6 seconds. Now recall, she's going down 20 feet for every second that passes. So 6 seconds have already passed, right? And we go down at a rate of 20 feet per second. So let's go back. Where was she 6 seconds prior to this place? So we're going to increase by 20 for 6 seconds. Well, 6 times 20 is 120. I'm thinking that when she got on the elevator, she started out at 470 feet. Because remember, as seconds pass, we're going down. So after 6 seconds have passed, she's now 350 feet above the ground. What is the value in the slope-intercept? What value in the slope-intercept form does your answer to part A represent? Well, it represents the y-coordinate of the y-intercept. Or we can call it RB. Now remember, B represents where does the graph cross the y-axis? So where is my starting value? Number 16, model with mathematics. Write an equation in slope-intercept form for the motion of the elevator since it started to move. What do x and y represent? Well, the formula, remember, is this y equals mx plus b. We said that the negative 20 represented my m, and the b was represented by the value of 470. So I'm going to say y equals negative 20x plus 470. What does x represent in this? X was my number of seconds. X is the number of seconds since entering the elevator. Y is the height of the elevator above the ground. And this is measured in feet. So again, X the number of seconds since entering the elevator. Y represents the height in feet above the ground. A. What does the y-intercept represent? Well, the y-intercept would represent the height above the ground in feet when she entered the elevator. Use the equation you wrote to determine at this rate how long it will take after Monica enters the elevator for her to exit the elevator on the ground floor, and explain your answer. Well, what does it mean to be on the ground floor? What do I know if I'm looking for the ground floor? Obviously, that y has to be equal to 0. And if I know that y is equal to 0, we should solve the equation we wrote, but I'm going to substitute in 0 for y. So solve the equation. 0 equals negative 20x plus 470. To find x equals, and I'm going to do this off to the side. 0 equals negative 20x plus 470. So I'm going to subtract 470 from both sides of the equation. So I got negative 470 equals negative 20x. Well, now I need to solve for x by dividing by negative 20, using my division property here. X equals, well, a negative divided by a negative is positive. 470 divided by 20 is 27. No, sorry, 23.5. So x equals 23.5. And remember that x represents the number of seconds. So what this is stating is that Monica must ride the elevator for 23.5 seconds before she actually hits the ground floor. And that's if the thing does not stop along the way. On to the wrap up of this lesson.